Alright, here we go. A nice little shortcut for you. Maybe you noticed it from the problems on the last page. But the power rule is a big rule that we'll use with derivatives to make things a lot easier. We don't have to do the full limit definition. I know you're whining, Mr. Mitchell, why did you make us do it in the first place? Just show us the shortcut. But you know what? Now you're going to appreciate it a little bit more and understand the meaning behind the derivative and where it comes from. For the power rule, if f of x equals x to the nth power, then the derivative of f of x is n times x to the n minus 1, which looks kind of confusing at first glance, but it's pretty simple. What we're doing here is we're taking that exponent and bringing it out in front. That's what we have here, the n out in front. And then we have to subtract 1 from the exponent. So after we bring that exponent out in front, then we subtract 1 from our exponent. So it's like a two-step process. Number 1 down here, we want to find the derivative of f of x. If f of x equals x to the fifth, bring the 5 out in front times x, and instead of to the fifth power, we're going to subtract 1 from that exponent. So we get 5x to the fourth. All right, number 2, another example here, derivative of f of x. We're going to bring the exponent out in front, even though it's a fraction, goes out in front, times x to the 4/3 minus 1. So we have to subtract 1 from that. So remember, 1 is the same as 3/3. So we end up with an exponent of 1/3. Now, if you look at 4, 5, and 6, these are asking for specific derivatives. So what you want to do is find the general derivative first and then plug in that number, kind of like we did with the long derivative with the limits, but much simpler here. Let's first find out what's the derivative of f of x. Well, it's just 4 times x cubed. But we're being asked to find the derivative of f of -2, which means after we find out what the derivative is, we're just putting -2 in the place of x. So the derivative of f of -2 gives us, well, -2 cubed is -8 times 4 gives us -32. So what this is telling us is this function has a tangent line at x equals -2 that has a slope of -32. So it's changing pretty quickly in a negative fashion, right? Slope of -32. So I want you guys to go ahead and take about a minute, if not a little bit less, and try 3, 5, and 6. About 10 more seconds. All right, let's go ahead and take a look and see how. All right, so for number 3, -7x to the -8th. Remember subtracting 1, so -7 minus 1 gives us -8. For number 5, 1/2 times x to the -1/2 for our derivative, but then we want to plug 4 in. So we get 1/2 times 4 to the -1/2. I didn't show the work here, but remember 4 to the -1/2, that means we're going to take 1 over 4 to the +1/2. But raising something to the 1/2 power is the same as taking the square root of it. So we really have like 1/2 times the square root of 1/4, or sorry, 1 over square root of 4. So that's 1/2 times 1/2 gives us 1/4. And then for number 6, -2x to the -3rd. Put -3 in there. Really, we have like -2 over -3 to the 3rd. And we get +2 over 27.